Tonight's movie is the first of two movies with the major heading of types of reactions. The subheadings of synthesis and decomposition we will get later on. The purpose of these two movies is to allow us to predict the products when we're given only the reactants. So these are in a particular order based on the ease of understanding the different reaction types, but not necessarily the order that we're going to think through, okay, is this reaction a such and such? Moving on to the first slide in 3, 2, 1. So our first reaction type is synthesis, which means coming together. Some people refer to this as the hookup. Those people typically are not chemists. What does it mean? General form is a term that means if I'm standing and looking at this from just a little too far away so I can't make out the exact chemicals, but I can see, oh, there's a symbol here and a symbol there, and some are pretty small that are elements and some are bigger, which are compounds. What would this thing look like? And so we see that there are two reactants and we end up with only one product. And in synthesis, we can have 2, 3, 4, almost any number of reactants, but you'll always get just one product. So the reactants in this situation could be elements, they could be compounds, which makes this a little harder to predict. In practice, synthesis is the last reaction type I will figure out, so I will work through a process, and when I get to the very, I've eliminated everything else, then it's going to be synthesis. An example would be sodium plus chlorine produces sodium chloride. This is a skeleton reaction, and the symbol NaCl does not have a subscript 2 because the NaCl comes from the crossover rule. Sodium's +1, chloride is -1. The key defining feature of a synthesis reaction, the key feature is there is only one product. If we want to look at this more for that hookup idea, oh, here's one reactant, and here's another reactant. What happens? Oh, aren't they a lovely couple? Moving on in 3, 2, oh, by the way, you don't have to draw the figures of the people. Moving on in 3, 2, 1. Decomposition, or breaking apart of something, also known as the breakup. The general form now is AB, which is some compound breaking apart into simpler substances, which could be elements, they could be compounds. But the reactants must be compounds. You have to have something that complicated to break apart into smaller things. But the A or the B in this case could be elements, could be compounds. An example of this, sodium bicarbonate. When we heat it up, we get sodium oxide, carbon dioxide, and water vapor. And so you'll get multiple products, but the defining feature of a decomposition is there's only one reactant. And this is the first question I'll ask when I'm trying to figure out what type of reaction is something, because the only type with just one reactant is decomposition. So it's the first one I check off my list. And if it's decomposition, I look for it to break apart into simpler things. What's this going to look like? Oh, isn't that a lovely couple? Oh, this isn't looking good. Oh, she's out of there. Or he's out of there. Yeah, they're both out of there. So, this is decomposition, the breakup, as opposed to synthesis, the hookup. These are called complementary reactions because they're doing the opposite things. In class tomorrow, we're planning to do a lab. In your textbook, it's section 6.7, and we'll be ending up doing parts A, B, and C. So if you have your textbook at home tonight, that's great, look it over. And if you don't, then when you get to class tomorrow, we're going to go over this PowerPoint, and then we're going to give you a few minutes while I set up a couple pieces of equipment, and that way you'll be all set to do the lab. Thanks for watching.